So here's where we are. What does LCM stand for? Very good. The least, come on, least common multiple. And the least common multiple of two whole numbers is the smallest number divisible by both of those numbers. So another way of thinking about it is to find the smallest number both of those would divide into. Not what divides into them, but what they could both divide into. So if I asked you what's the least common multiple of 3 and 9?
3.
You just gave me the greatest common factor. That's the smallest number that divides into both of these numbers. I want to know what's the smallest number both of these will divide into. In other words, if I were looking for a common denominator, it would have to be what? It would have to be 9. If I were, because the least common multiple is the same thing as finding a common denominator. And so here's going to be the first thing that I would suggest. Okay? Keep in mind, it can never be smaller than the larger number. So when I am looking for my least common multiple or my common denominator, and I look at these two numbers, the first thing I'm going to check to see is if the largest number might be it. And the way that that number would be it is if the smaller one divides evenly into it. So since 3 goes into 9 evenly, that means 9 is my LCM. Or it would be my common denominator if we were working. And the reason we're doing this is so we can find common denominators. Now, if I look at the next one, I need the least common multiple of 6 and 8. So if I look at this, and I know it can't be smaller than the larger number, 8's bigger, will 6 go into 8 evenly? So I got to have another way of figuring this out, right? Okay, so if I try to divide the smaller number into the larger and it doesn't go evenly, here is a cool way to figure this out. Now, some of you came up with a number that tells me you're pretty good with your times tables, you kind of know what you're doing, and that's great. For those of you who say, man, this stuff's always been hard for me, here's what you can do. You're going to multiply these numbers together. So 6 times 8 is 48. That is a common denominator or a common multiple, but it's not necessarily the least. And here's what I would do after I multiply these together. You guys are pretty good at finding greatest common factors. So look at 6 and 8. Do they have a common factor? What would divide into both of them? 2. So after you multiply these together, divide by the GCF. So if I take 48 and I divide it by 2, that's how you get 24.
So 24 else.
24 would be the answer on that. That's the smallest number that both of those would divide into evenly. Now, there are other ways you can find it. Let me just kind of show you real quickly. You know, we talked about prime factorization last week. So if I did my prime factorization for 8, what can I multiply together using prime numbers to get 8? 2 times 2 times 2, right? Our prime numbers are numbers that are divisible only by itself and 1. And then 6 is 2 times 3. So if I wanted to use prime factorization, I can. The way it works is if I'm looking at any common factors, I'm going to keep where the most show up. I have 3 2's here, only 1 2 down here. So I'm going to keep all these guys. And I don't need that one because I already have all the 2's that I need. And then I've got to use this one because you've got to use every factor that shows up. You're just going to keep where it occurs the most. And 2 times 2 times 2 is 8, and 8 times 3 is 24. That's another way you can find it. There's a lot of different ways you can find it, but this over here is probably the easiest way to find it if the smaller number doesn't divide evenly into the bigger. Okay, now let's see if you can get the least common multiple of 4 and 7. What do you think? 28. And why is it going to be 28? Exactly, because 4 won't go into 7 evenly, so I multiply them together. 4 times 7 is 28. But what's the greatest common factor of 4 and 7? What's something that divides into both of those? 1. 28 divided by 1 is 28. Okay, so we could use prime factorization, or we can use this method. Now, if you look at this, look what happens when the numbers start to get a little bit bigger. This is 28 and 98. Okay, so I have a question for you. Before we could add or subtract fractions, you have to have what? What kind of denominators?
Common.
Common, or like denominators. So let's pretend we had fractions, and one fraction had a denominator of 28, one had 98. Now, I've given you 2 options on how you could find your common denominator. You could do what we talked about here. Multiply these together and then divide by the greatest common factor, okay? Or I could use prime factorization. What do you think might be easier?
Prime.
On this one, yeah, I mean, you can go either way. If I were to ask you what's going to be the largest number that goes into both 28 and 98 evenly, is that something you're easily able to identify? I know 2 will go. Do I know if that's the largest number that will go evenly?
18.
Well, 18 won't go into 28. So what I'm saying is, if you're not real confident that you're going to find the GCF that easily, let me just show you. If we did it with, actually, I better do it on here, so we've got a recording of it. If we did 28 with the prime factorization and 98 with the prime factorization, let's see what we come up with. Now, 28, for those of you who weren't here, we said we can take this number and do a little backwards division. And our prime numbers are numbers that are divisible only by itself in 1. So what would be the first number? Exactly. If it's even, start with 2. 2 goes 14 times. That's still even. So go again with 2, and it goes 7 times. So I'm going to get a 2 times 2 times 7. Now, if I do 98, start with 2. That goes 49 times. Now, that's not even, but what goes into 49? Yes, 7 times 7. So I've got 2 times 7 times 7. Now, see if you can help me figure out what would be our common denominator or our least common multiple. I got to check and see the only numbers that show up here in the factorization are which ones? I have 2s and I have 7s. So I'm going to check to see where did I have the most 2s, on top or on bottom. So I keep the ones where they occur the most and I get rid of the other one. Where do I have the most 7s? On the bottom. So I'll keep where they occur the most and I'll get rid of the other one. Now I'm going to multiply everything together that I've circled up. 2 times 2 is 4 and 7 times 7 is 49. So if I do 49 times 4, that's going to be my common denominator or my least common multiple. So that's going to be a 6 and carry a 3. 4 times 4 is 16 plus 3 is 196. That's not too bad, is it? So if the numbers get kind of big, you may find using this process of the least common multiple will be helpful. Where we do the prime factorization, if the numbers aren't too big, you may just want to multiply them together and divide out by the greatest common factor. Okay, the more we practice, the better we're going to get. So let's look at these guys. Part of what we've got to learn to do is once we know what needs to be our common denominator, we've got to figure figure out how to rewrite our fraction as something that means the same thing, but uses the new denominator. So here's a little practice on that. Let's say we had the fraction 2/3, and we wanted to rewrite it as a fraction that has 15 in the denominator. So what could we multiply times 3 to get 15? 5. So if I'm going to multiply the denominator times 5, what do you think I'd have to multiply the numerator by? It's got to be the same thing, because I'm multiplying by something that means 1. And how much is 5 times 2? 10. Okay. So
I thought this way. I thought you were supposed to multiply.
you can. That's a good comment. So let me just kind of show you. If you thought about this, it's actually a little more advanced way of finding it. This is more of using a completely algebraic method. If this were an X, and I want to know what that number is, remember, cross multiplying only occurs if there's an equal sign. Since I want these two to be equal, if I multiply this way, 2 times 15 is 30, and that would equal 3 times X. So to find X, I would divide both sides by 3, which gives us 10. So that's another way you can find it, all right? That would be using proportions and cross multiplying. So it doesn't matter to me which way you go. You can either say 4 times what gives me 16, and whatever the number is, I got to multiply the top by it, or you can cross multiply. So what do you think we're going to get here? Yeah, because if I multiply this times 4 to get the 16, I got to multiply the top times 4, and that's going to give me that numerator. How about this guy? What would you multiply 16 by to get 32? 2, which, by the way, if you look at that and you say, I don't know, what could you do with your calculator to figure it out? Yeah, take 32, divide it by 16, and see what that number is. And since it's 2, if I multiply both top and bottom by 2, what's my new numerator? 14. Okay, I want you to do the last one yourself. We're going to see what you get. Okay, some of you are quick on the draw, which is good. So if I were to ask you on the count of 3 to tell me the number you think belongs here, let's hear what you say. 1, 2, 3.
18.
Now, quick show of hands. If you're feeling really good about where we are, I want to see a thumbs up. If you're not, thumbs down. If you're kind of, I'm getting there, but I need a little more work, give me this. Okay, so far everybody's doing well. And one of the things we talked about last class was if we run into something where everybody knows this, we'll try to go through faster. If it's something where I need to slow down, you guys give me feedback, and we'll do that as well. All right, so let's see if you know the rules. If we're going to add or subtract fractions, we must have what? Common denominators. Good. Must have common denominators. If they're different, here's what we will do. We've got to rewrite the original fractions. So put original here, whatever they give us in the problem. We're going to rewrite those original fractions as equivalent fractions. Now, what does equivalent mean? Yeah, it's kind of a fancy word for saying equal. They mean exactly the same thing. They're just going to look a little different. And because you're going to have the least common multiple as the new denominator. And when we are working with fractions, we call it the least common denominator. Now, once I get the common denominator, then I will add or subtract just like I would with like fractions. And then what's the last step? Always check to be sure to reduce. Reduce the answer, if possible, by writing it in lowest terms. And we're not going to use mixed numbers, but if it turns into a whole number, then you're going to write it as a whole number. So let's see if we can take care of some of these guys. We have 1/2 plus 3/8. Now, when you know what the LCD should be, I want to see a hand. Don't say it, just raise your hand so I know you already figured out what's going to be the common denominator. 1/2 plus 3/8. I see a few hands, not a lot. So what do we say is the way we're going to figure this out? The first thing you want to try is what? Okay, look back at what you wrote down a minute ago. Okay, back before that, I gave you like a 2-step process on how to get an LCD. And the first thing I asked you to try is to see if the smaller number will do what? Divide evenly into the larger. Will 2 go into 8 evenly?
Yes.
What does that mean my LCD is? The LCD can never be smaller than my biggest number.
So
It's 8. And that's because 2 goes into 8 evenly. Okay, if that works, that's the easiest thing. Now, I know what the LCD is. What am I going to have to do to this first fraction? Multiply it by 4. So if I were to take 1/2 and multiply it by 4 over 4, what does that give me? 4 over 8. Now, I look at the next fraction. Does it need to change or is it good? It's good. I'm going to leave it as 3 over 8. So if I add those, what do I get? 7 over 8. Isn't that pretty easy? Then you guys do the subtraction one yourself. I want to see if you can do that. And when you think you've got the answer, I want to see a hand. One. So while you're finishing up, those of you who've gotten an answer, see if you can answer this for me. We said after we add or subtract, the last step would be to see if something, if the fraction would reduce. Did your answer need to be reduced or not?
No.
It didn't need to be reduced. So as long as you can get the common denominator, when you finish, your answer should be in simplest form. One more question while a few people are finishing up. Did your answer end up being a proper fraction or an improper fraction? Proper. And that means that the number in the numerator is smaller than the number in the denominator. Okay, on the count of 3, I want you to tell me what you think the answer is. 1, 2, 3. 3/8 or 3 over 8. Very good, because again, the LCD is 8. Because if I divide 4 into 8, it goes evenly. So that means that this 1/4 is the fraction that's got to change to turn into something with an 8 in the denominator. And I could multiply by 2 to make that happen. So that's the same as 2 over 8. So when you took 5 over 8 and you subtract 2 over 8, that's how you get 3/8.
So you write it down.
When I'm trying to get my common denominator, if this is going to have to change, then I ask myself, what can I multiply that denominator by to turn it into what my LCD needs to be? Yes. And whatever I multiply the denominator by, I've got to multiply the numerator too. Okay? If you wanted to set it up as a proportion, you could write it as 1 over 4 equals something over 8, and you could cross multiply and come up with a number that way too. I just find more students probably get lost at this point in that process than just changing it this way. Now, if you look at 2, does this look like this should be easy or would this be hard? You think it's going to be easy? Can you do it? I want to see if you can add these 2 together. It's pretty similar to what we've been doing. So let's see what you come up with. got it yet? So if you got your answer, did it have to be reduced?
No.
No. So how many of you have an answer? Let me just see a quick show of hands. One, two, three. Okay. On the count of three, tell me what you got. 1, 2, 3. Awesome, guys. So this guy was good. And this one, we figured out 6 would go into 12 evenly. So all we had to do is multiply that fraction by 2 over 2, right? Which meant 1 over 12 plus 10 over 12 is how you got 11 over 12. So as long as only one fraction needs to be changed, because the smaller number divides evenly into the larger, are we feeling pretty good? What's different about this number 2 over here? It's subtraction, and I've got 5 and 4 as the denominator. Will 4 divide into 5 evenly? That means 5 cannot be my LCD. I got to find it. All right, see if you can figure out what the LCD should be. Don't call it out just yet. When you think you know it, let me see hands so I can tell how quickly you're getting it. I got about half of you. And where do you think it is? And why do you think it's 20? Because if I multiply 5 times 4, I get 20. And what's the largest number, the greatest common factor that goes into both 4 and 5 evenly? Just 1, right? 1's the only number that divides into them. So if my GCF is 1, my LCD is going to be what I get when I multiply them together. Now, that means both fractions have to change. So if I need this to be something over 20 minus something over 20, I've got to take 4 over 5 and multiply it by something to get 20 in the denominator. What number would that be? No, not add, multiply. 5 times what gives you 20? 4. And if I'm going to multiply the bottom by 4, I'm going to do what else? Multiply the top. So what's my numerator? 16. So I'm going to have 16 over 20 because that's the same thing as 4 over 5. Now you guys change 3 over 4. See if you can tell me what belongs here if I take 3 over 4 and turn it into a fraction.
Just 10.
Say again?
Just 10. So that means it's 10, like 10.
Well, don't say it yet, but yeah, you're going to figure it out. Then I'm going to ask you. Okay. So you got to multiply 4 times what to get 20? And if I multiply top and bottom by 5, that means my numerator is, and if I put 15 here, when I subtract, my answer is 1 over 20. Okay, I want to see those hand signals again. How many of you say, I'm actually doing okay with this? I think I got it. All right. I say, yeah, probably need a little more practice. I'm getting there. Okay, got a few. So on number 3, we got 5 over 8 plus 1 over 3. So let's think about that for a second. Can we figure out what the LCD might need to be? We have a disagreement. I've got a 16, I've got a 24. Let's see if we have anything else. So I got an 8 and a 3. Will 3 go into 8 evenly?
No.
No. So I do what with those numbers? 8 times 3 is? And what's the greatest common factor between 3 and 8? What will divide into both of those evenly? Only 1. So that means 24 is my LCD. Okay, makes sense? All right, you guys see if you can go the rest of the way with it. Now that we know what the LCD should be, I'm going to walk around the room and I will help if you need some help. A little more practice, but we're going to keep practicing. So since the common denominator was 24, 8 had to get multiplied by what to give you 24? And as long as I'm multiplying the bottom by 3, I better also multiply the top. So 15 over 24 is what we get for this first fraction. Then we're going to add to it whatever 1 over 3 turns into when we make the denominator 24. And what did that have to get multiplied by? 8. Good. 8 on top, 8 on bottom. And if I add 15 over 24 plus 8 over 24, that's how I get 23 over 24. Okay. If you decide you need more practice on this, let me know when we get to where we're in the lab, and I will give you a little extra. You can practice on that. Now, how many of you guys have heard of PEMDAS before? Please excuse my dear Aunt Sally, right? Why do we need PEMDAS? What? So you get the right answer. I like that. It stands for parentheses. What is the E? Exponents. The M and D are multiplication and division. They count equally. Add and subtract. And the whole point of knowing that is it tells you the order you simplify things in, because if we don't do it in the right order, we can get different answers. And they're not, have you ever seen like on Facebook or something those, oh, only, 1% can answer this problem, and it's something that involves order of operations, and then you look at the comments and there's probably 15 different numbers that show up because people are not following the order of operations rules. So here's what you do when you see something that involves more than one operation. You're going to first ask yourself, do I have any parentheses? Because if I do, and there's numbers inside the parentheses that I can actually combine in some way, I want to simplify what's inside the parentheses, but I don't have any here. So I don't see any exponents, but I do know I've got a dot for multiplication. I've got a plus sign for addition. Now, I want you guys to see if you can figure out what the right answer is going to be for number 3, but don't call it out yet. We're going to see if you all already know the right way to do this. Okay? So you got 7 plus 3 times 8. On the count of 3, I want you to tell me what you think that simplifies to be. 1, 2, 3. 1. I think that almost sounded like that was in perfect unison. I was expecting to not get the same answer. That's impressive, because according to order of operations, what do you have to do first? Multiplication. I've got to multiply these two guys together, and that means this is 7 plus 24. Now I can add, and that's how I get 31. I really thought somebody would tell me 80, and I'm glad you didn't, because if you did, you were just doing it as you saw it from left to right, not paying attention to order of operations. We've got to take care of any multiplication or division before we can add or subtract. Now, look at 4. Tell me what you need to do first. This one has a parentheses that I can simplify. So I'm going to do that first. And what that means is I am going to copy everything else just like it appears, except inside that parentheses, instead of 8 plus 1, I'm going to put what number? 9. 8 plus 1 is 9. Now, let's think order of operations. I've done the parentheses. Do you see any exponents? No. But do you see any multiplication or division? Yes. So now, in fact, how many different times is there multiplication? There's twice. So I'll do it in order from left to right, but I'll only do multiplication. So what's the first multiplication you see? 7 times 6 is 42. My subtraction I'm not doing yet, but what else gets multiplied?
8.
3 times 9 is 27. Does that make sense? Okay, now subtract that. What? So if I do 42 minus 27, what's that going to equal? 15. Good job. Okay, now what does this mean when I've got a bracket and then I've got a parentheses? What's a bracket?
Bracket's like, it's like box.
It looks like it's a parentheses, it's been squared off, it's like it's boxed in. We use them if we have more than one set of parentheses, and that just helps keep us organized so that we are clear on this inside parentheses is separated from the outside parentheses. So if we're going to solve this, what do I do first? The inside parentheses or the outside? Inside. You work your way in to out if there's more than one set of parentheses. So I'm going to have the 9. I'm going to leave the bracket, but what do I do with that 4 plus 8? It's 12. And that means I'm going to have 12 minus 3 inside that bracket. Now, how much is 12 minus 3? So let's see if you guys can tell me what this is going to equal.
81.
Good, because this is 9 times 9, which is 81. All right, how we doing? So far, so good? Okay. What is the only thing that's a little different when it's a fraction? Do the top separately and the bottom separately before you worry about cleaning up the fraction, okay? So I want you guys to see what number belongs on top, then you're gonna see what number belongs on bottom, and then we'll go from there, okay? So you work on that. When you think you've got it, I want to see hands. By the way, while you're doing this, let me mention, because I didn't really get into this last time, I know for some of you, the idea of writing out your work is something you don't like to do. However, when we take tests, I'm going to, I don't really care as much about the answer as I do care that you show me you understand how to get it. Now, some of this that we're reviewing right now is very simple. I've given you the heads up, though, that when you're doing your homework, you want to be in the habit of writing the problems down, showing the steps, and as we get into things that are more difficult, if you give me an answer without work, you won't get credit, okay? So just be aware of that. This has enough steps in it that you should write something down before the final answer, okay? So how many of you have a number that goes on top? Okay, that's most everybody. So if you've got the number on top, if you also got the number on bottom, you think you know what your final answer is. So did this end up being an answer that's a fraction? Or did it end up becoming a whole number? Oh, let's see what you got. So on top, you ended up with what number? 32, because if you do 7 plus 8, that is 15. And then 2 times 15 is 30, and 30 plus 2 is 32, right? Over. Now, tell me what number you got on bottom. You should have 16. Why? What do you have to do first? The 3 times 5 gives you 15, and 1 plus 15 is 16. And what is 32 divided by 16 equal? The whole number 2. Now, if you got 20 on the bottom, you didn't do order of operations correctly because you can't add before you multiply. All right, we good? Then let's talk just a little bit about the number system, because we're going to see some questions when we get into section 1.3, where we're going to be doing some classification of numbers. So I don't want to spend too much time on this, but I want to give you a little background. When you see these, now we already looked at parentheses, we looked at brackets, which are the squared off ones. These are the ones that are kind of wavy. It's set notation is what it's called. and they're braces. And so braces mean everything that's inside is a group together. We call it a set. Elements would be the objects that are in a set. And so if we talk about sets of numbers, let's talk about where numbers came from, okay? So anybody in here have like little brothers or sisters, or maybe you've done some babysitting, been around little kids? All right. So let me ask you something. If you got a little one, what's usually the first thing they learn to do with numbers? Count. They first learn to count, right? And so if they're learning to count, what number do they start with? Do they start with 100, 101? What do they start with? 1. And so these are called the counting numbers. And the set starts with 1 and goes up from there. 1, 2, 3, ... Okay? And it's kind of interesting. Little kids start with the number 1 because 0 doesn't typically have a lot of meaning for them yet. In fact, did you know, I think the Mayans are the ones who are credited with coming up with the concept of 0 as a number, which means there was quite a span of time that nobody really contemplated that there was the number 0. But with the next set of numbers, we're going to call those the whole numbers. That's going to include 0 with the counting numbers. So we don't take anything away, we just add to it. And I'm going to give you a little illustration over here with a little diagram. So if we have the counting numbers or the natural numbers, all right, when the kid gets a little bit older, think about maybe the kid who's sitting in the high chair and he's eating his Cheerios and he's so proud of himself because he's learned how to count. Big brother comes in and he says, how many Cheerios do you have? And so the little one's counting 1, 2, 3, and big brother grabs all of them and says, now how many, and runs off, okay? Like big brothers sometimes do. What you have illustrated to the little one is the idea of the number 0. Now, when he's a little bit bigger, he'll get the idea about what 0 means, all right? And in the real world, we know we can have 0 of something, right? Absolutely. Hopefully, it's not your bank account, but if you didn't know that, it can get even worse because eventually you learn a little bit about negative numbers. So that's called the set of integers, okay, which you can think of as number line numbers. And so after you have the natural numbers, you move up to the whole numbers, which includes 0, ... And then the set of integers would be positives, negatives, and 0. But what do you notice we haven't addressed yet that we know are numbers? What kind of numbers? What have we been working? Fractions. Fractions, decimals, all those kinds of things we haven't even talked about. When you're working with little kids, you don't start with fractions, do you? In fact, you probably thought numbers were okay until you got fractions, and then you kind of went, ah! All right? So if we were going to work with these number line numbers or these negative numbers and positive numbers, we're going to end up with some rules we're going to need to learn, which we're going to talk about in a little bit. But first, give me an idea. I've given you one illustration. Let's say your bank account is one place in the real world where negative numbers might appear. What's something else where you take into account negative numbers? Don't we have some football players in there? Okay, so what would be an example in football where negative numbers might show up? Okay, so you could have a loss of yards. on a football play. Okay. Penalties. You get penalized, that means you're getting yards taken away, right? So negative numbers. Anything else you can think of? Okay, we'll let it go with that for now. But there are places in the real world. Now, I will tell you, we have more sets of numbers than this because we've already said there are fractions and decimals. So things like 1/3, decimals like 0.72 or 0.13, and that 3 repeats. Anything that is a decimal number that repeats or ends, or it can be expressed as a fraction, that's called the set of rational numbers. Because in the word rational, do you see ratio? And ratio means you can make a comparison of two numbers by using division. So in other words, if it can be written as a fraction, that makes it a rational number. Now, that means all of these numbers we've talked about are included in the set of rational numbers. So how do I make a whole number look like a rational number, look like a fraction? Like the number 3. Can I make it look like a fraction? By doing what? 3/1. Just because it might not look like a fraction, the way that it's written, if it can be written as a fraction, that's what makes it rational. So all of those would be the set of rational numbers. We still have more numbers. Let's see if you remember these. Do you remember seeing something like this? What is that symbol? Pi. What is pi? 3.141599 ... Because it's a decimal number that doesn't end and it doesn't repeat. We have some other numbers. We're going to talk about the number e later. It's kind of like pi. It represents a number, a number that doesn't end and doesn't repeat as a decimal. You could have 2.154 ... Okay, here's another one. What about the square root of 5? Have you ever put that in the calculator? What is it? A decimal number that doesn't end and doesn't repeat. That means if these are the rational numbers, this group is called the set of irrational numbers. If it's irrational, it's because you can't express it as a fraction. Now, like pi, we have a approximation we can use for it, but it doesn't exactly equal either a decimal number or a fraction. And if you put all this together, we call this the set of real numbers. So when you walked in here today, this was probably the set of numbers that you're most comfortable with, that you are familiar with because you've been working with them for a number of years, okay? And so irrational numbers mean in decimal form, they never end, they never repeat. And one of the things we're going to get to when we get to chapter 3 is something called the set of complex numbers. And I think I'll wait till we get there to tell you about those. Believe it or not, there are more numbers than just these. All right? Have you worked with complex numbers before? Does that ring a bell? What about imaginary numbers? You heard of those? Okay, we're going to be talking about those. Just not yet. Okay. And this was, oops, I had that there. Well, let's see if we can remember how to fill this in. Okay, so what was the very beginning group? Natural numbers, which start with 1, 2, 3, ... Okay. The next group after that was the set of whole numbers, which because we take the natural numbers and we add in what? 0. So it's 0, 1, 2, ... Okay. After that, What's the next set? What do we add in next when we're learning about numbers? It's called the set of integers because now we're going to have what kind of numbers added in? Negative. So dot, 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 maybe -2, -1, 0, 1, 2, dot, dot, dot. Okay. And then what was missing that we want to add in here? Rational numbers. And the set of rational numbers includes what? Fractions. So things like 1/3. What else?
1/2.
Yeah, any fraction, 1/2. What about 0.23? If it's a decimal number that ends, or what other kind of decimal? Repeats, like 0.6 with a bar on top, okay? If it's a decimal number that repeats, it can be written as a fraction. So all of those are rational numbers. There's one more example I didn't give you a minute ago. What's the square root of 4? 2. If it's a perfect square that we're taking the square root of it, that's a rational number. But these irrational numbers are the ones that can't be turned into fractions. So that's where it's things like pi, e, which is the natural number e, square root of 7. The square root is not a perfect square. Or if we have a decimal number like 2.13459 dot, 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 a decimal number that doesn't end and doesn't repeat. Those are all irrational numbers, and when you put them all together, it makes the set of what? Real numbers. Very good.
Going to the lab today?
We will, but it'll be a little bit before we go. We gotta get some more notes done. Okay, so we want to cover these sign rules that go with, now that we're going to be pulling in positives and negatives. We're going to just work with this set of integers to get the sign rules down, but they're going to work with all the real numbers. So even if we have fractions or decimals, the sign rules still are the same. So if I were to ask you right now, how many of you know what you're supposed to do if you're adding a negative and a positive? How many of you feel confident, like if I gave you -7 plus 11, that you could figure out the answer pretty easily? Okay, I've got maybe half of you who are feeling good. That means there's probably half of you who say, I think I need a little bit of review on that. Agreed? So let me give you some rules you can follow. Now, when you first learned how to do this, anybody remember maybe back in, I don't know, either late elementary school, well, actually, before you start working with negative numbers, when you were just learning to add numbers, did you ever have like a number line on your desk, like maybe beans or chips or something, and you had to move them on the number line to get your answer? Okay, sometimes we do that. So there's a number line here just to quickly remind you of here's why it works, and I would be stunned if there are any of you who feel like I can't add 1 + 4 without a number line. But if you want to see visually, just to remind yourself how this works, I'm going to put 0 on here and number off a few places on the number line. And so if I just needed to see how this works, this is going to tell me start at this number. So I'm going to start here at 1. I'll put a box there. And if I'm adding 4, is 4 a positive number or a negative number? Positive. If I'm adding something that's positive, which direction do you think I go, right or left? Right. If I move to the right, that's positive. If I go to the left, that's negative. So if I move over 1, 2, 3, 4 places, what does that tell me my answer is? 5. Now, you don't need a number line for that. I know that. But how many of you say, I know what to do on -2 + -5? Okay, a few hands, not quite as many. So let me just show you visually how this works. So let's say here's 0, and then we have -1, -2, 3, 4, 5, which by the way, don't forget, our number line gives us the number of units we are from 0. If it's positive, it means we're that many places from 0 on the right side. If it's a negative number, we're that many places from 0 on the left side. So if we do the same thing here, and we start at -2, and I want to add -5, which way am I moving? To the left, because a negative number means I've got to go to the left. So I'm going to go 1, 2, 3, 4, 5. What would you tell me the answer is to -2 plus -5? -7. Now, here's the shortcut way of getting the rule. If I'm adding or subtracting, I'm going to pay attention to if my signs are the same or if they're different. So if they're the same sign, either both positive or both negative, okay? My rule tells me that I will add, and actually, let's do this. Let's just write the rules for addition. I'm going to tell you what to do for subtraction in a minute. So if we're adding, we're going to add the absolute value of the numbers. All right, now what does absolute value mean? Like, for example, if I asked you, what is the absolute value of -5? What would you tell me? 5. What's the absolute value of +5? Whoa. It's 5. And the reason is absolute value is just saying, what is the distance this number is from 0? And I don't care whether I'm going to the right or the left. So the absolute value is always what sign? A positive. Okay. So this is telling me it doesn't matter if both of them are positive or both of them are negative. As long as the signs are the same, I'm going to add the numbers, the absolute value of the numbers, which means the positive value of the numbers, and I will keep the same sign for my answer. So that's why if I add 1 plus 4, I get 5, and because they were both positive numbers, my answer is positive. If I'm adding 2 negative numbers, I don't pay attention to the negative signs. I add the 2 plus 5 and get 7, and because they were both negative, my answer will be negative. Does that make sense? So if the signs are the same, we're going to add the absolute value of the numbers and keep the same sign. All right, so very quickly, let's see if you guys can tell me what these would be. So are these signs the same? Yes, so what would be the answer to -7 plus -3? -10. As I add the numbers, the 7 plus 3 to get 10, and keep the same sign. What's 4 plus 6? +10. What would a -15 plus a -4 be? The sign is going to be negative, and because the absolute values are 15 and 4. 15 plus 4 is 19, and that's why the answer is -19. Now, give me a quick signal. As long as the signs are the same, and I'm asking you to add, are we good or not? Where are we? Okay, so we're probably most of us here, some of us somewhere between here and here. We'll keep working at that. Now, look at what happens if the signs are different. Okay, I'm going to go back to the number line for a minute. And so let's say 0's here, 2, 4, 6, and I'm going to add a +6 and a -3. So if I start at +6 and I want to add a -3, which way do I go 3? Left 3. So I'm going to go 1, 2, 3. What number is that? A +3. Okay, let's do one more of these. So let's say this is 0, -1, 2, -3. This is a -5. Okay, so if I started a -5 and I want to add 1, which way do I go? Right. And if I go right 1, where does that put me?
-4.
At a -4. Now, do you see a rule or a pattern we can use if we're adding and the signs are different? Remember, when the signs were the same, we added the numbers and we kept the same sign. Are we adding the numbers here? Did I add 6 plus 3 to get 3? No. And I didn't add 5 plus 1 to get 4. What did I do with those numbers? That's it. You are going to subtract the absolute value of the numbers. Now, that's how I get the number part of the answer. How do I figure out the sign? Because this one had a positive for an answer. This sign was negative for the answer. Where do you think the sign part of the answer comes from? Take the sign of the number that had the larger absolute value. Okay? So if the signs are different, one's positive and one's negative, don't, after I say, hey, I'm adding 2 numbers, but the signs are different, just look at the number part, don't pay attention to the sign, and subtract to get the number part of the answer. The sign part of the answer comes from whichever number would be the larger number, the absolute value of it is larger, and take that sign. So when I look here, 5 minus 1 is 4. To get the sign, I go back and say, which number would have, what was the sign of the number that was larger, if I'm thinking about absolute value? And 5 is bigger than 1, and since 5 was negative, that's why my answer would have a negative sign. Does that make sense? And if you're having any trouble with it, you can always do a number line. The problem is if the numbers get really big, that's a little tough. What else am I not going to restrict you from using? A calculator. But I'm going to caution you. You really need to know these sign rules, because we're going to find there's something that's going to be coming up pretty soon that you need to know how to do this. And the calculator isn't going to be able to take care of it for you, because you've got to have an understanding of this rule and how the numbers work. Okay? All right, so let's see if we can figure these out. So I've got -8 plus 2. All right. So first question is, am I adding numbers where the signs are the same, or are they different? So when they're different, what do I do with the numbers? Okay, I heard the word subtract. If I subtract 8 and 2, I get what number? 6. Now I've got to decide, is my answer going to be positive 6 or negative 6? What do you think it is? And why is it going to be negative? Excellent, because the 8 is a bigger number than the 2, and the 8 was negative, so my answer is negative. Okay, I want you to see if you can do the next one yourself. All right. So I'm curious, did you end up with an answer that was positive or negative? Was it a single digit or 2 digits? All right, so on the count of 3, tell me what it is. 1, 2, 3. Negative 11, very good, because 4 and negative 15, different signs. So I'm going to subtract. 15 minus 4 gives me the number 11. But 15 is bigger than 4, and 15 is negative, so my answer is negative. All right, tell me how you're feeling. Good, okay. What about this one, negative 42 plus 42?
0.
Those are opposites, right? Even though one's positive and one's negative, if I recognize that the numbers are the same, but one's positive and one's negative, I know when I add them, I get 0. Now, I could still use the rule. 42 minus 42 is 0. But 0 doesn't have a sign. It's not ever going to be positive or negative. So see if you can tell me what goes here. If both numbers have the same signs, then what do? Without telling me about the sign, how do I get the number part? What do I do with the numbers? Add. So I'm going to add the absolute value of the numbers and keep the same sign. But when the signs are different, then I do what? Subtract the absolute value of the numbers, and then my answer does what? That's right. I'm going to take the sign of the number that has the larger absolute value. Those are my rules. Now, there's a little tweak that will add to this for subtraction, but I'll show you that in a minute. Right now, let's see if we can put this in with order of operations and not get lost. So on G, you see 2 plus, and then I see a bracket, and I've got 7 plus a negative 3 inside that bracket. So let's see if you can tell me what you would do first. 7 plus negative 3. So I got to figure out how much will that be. Okay, he's suggesting the answer is 4 when you add 7 plus negative 3. Y'all agree? So y'all concur? Because these signs are different, so subtract the numbers. Answer takes the sign of the larger number. 7 was bigger, so that makes it positive. So what would this equal? 6. You guys do H. I want to see if you can get it. When you got it, let me see hands, just so I know. Okay, so you're pretty speedy. It's good. So question, did you get an answer that was positive or negative? Positive. Was it single digit or double digit? Double digit. On count 3, tell me what it was. 1, 2, 3. 16. I hear a lot of 16s. Let's make sure they're right. You did which part first? Parentheses. So how much was negative 2 plus 5? Good. Signs were different, so I subtract the 2 numbers. My answer takes the sign of the larger number, and that meant I had 3 plus 7 inside this bracket, and 3 plus 7 is 10, and 6 plus 10 is 16. Okay, so you've got to make sure you know your sign rules and you know your order of operations. Now, let's look at this. Here you go, football guys. Football team lost 8 yards on first down, lost 5 yards on second down, but then they gained 7 yards on third down. How many yards did the team gain or lose altogether on these plays? How could we represent that using numbers and figure it out? If you lose 8 yards on first down, that's what number? Negative 8, right? Plus, what happens on second down? Lost 5 more, so minus 5, plus what happened on third down? Gain 7. Okay, so tell me, how did they do on that drive? They lost some yards, right? Yeah, they're not doing too well. So negative 8, and by the way, can I just pick 2 of these and add them up and then add something else to it? Absolutely. So if I do, because if I'm adding, I'm just going to do it in order from left to right. Negative 8 plus negative 5 is how much? Because the signs were the same, so you add the numbers, keep the same sign. And now I'm adding a negative 13 plus 7. And you told me just a minute ago, that means what on this drive? They lost 6 yards. All right, are they going to punt? Unless they're really dumb, right? Okay, or they're in field goal range. But yes, they lost 6 yards on that drive. Now, that's an example of a real world application. I know we do that a lot without stopping to think. We're really paying attention to some sign rules here. Okay, do not worry about this vocabulary. I'm just going to give you a little extra. We're going to add to our rules so we understand what to do with subtraction. And I want you to notice something first. If we were using the number line, and it's up to you whether you use it or not, okay? If I'm starting at 6 and I want to add -2, where am I going to be on this? How much is 6 plus -2? That's a +4. If 2, 4, 6. If I started at 6 and I add -2, which means I go 2 to the left, that puts me at 4. I don't even need a number line for this. If I have 6 and I subtract 2, what do I get? 4. Those are the same. Look at this guy. -4 plus -3. Now you guys use your sign rules that we just did a minute ago. Those signs are the same. So what's that going to equal? Say it one more time. -7. The signs are the same, so I add the two numbers and keep the same sign. Now, I want to show you what happens if you do -4 minus 3. So let's say -4, -6, -8. So let's say we start at -4, which is right here, and I want to subtract 3. If I'm subtracting, which way do I go? To the left. I'm going to go 1, 2, 3. Where am I? Those are the same. Now, my hunch is this you might be okay with now since we covered the rule. For sure, you were okay with that. This, you're probably okay with since we covered the rule. This one is the one that gives a lot of people trouble, okay? And here's something you can do that will help things out. Have you ever heard of subtraction being described as adding the opposite? Adding the opposite. I want you to look at this. Opposite means the opposite sign. So if I had subtraction, A minus B, that is the same thing as A plus -B. In other words, when I have a subtraction, if I will think of it as making 2 marks to turn it into an addition sign, plus a negative. I got to make 2 marks. I can't make 1. I can't just take subtraction, negative, plus sign and be done. But if I make 2 marks, that is the same thing as a subtraction problem. And then guess what? We already know the rule on how to add, whether the signs are going to be the same or the signs are going to be different. So as long as you turn your subtraction into adding the opposite, you don't need another set of rules on how to work with signs. You can use the set of rules for addition. That's what happens here. Look at this. If you have -4 and you turn this into adding the opposite, that's why it's the same thing as -4 plus -3. That's just a different way to write a subtraction problem. Okay? So that's what we're going to do as we work with these guys. And let's practice a little bit here. Okay, so if I were to ask you how you could rewrite 6 minus 10, so it looks like addition, it would be what? 6 plus a -10, because I'm going to add the opposite, make 2 marks. Now, let's see if you can tell me how much 6 plus -10 is. All right, I got several of you who quickly said -4, because are these signs the same or different? Different signs. When the signs are different, you do what with the numbers? Subtract, and then your answer will take the sign of the larger numbers. Since 10 is bigger than 6 and 10 is negative, that's why it's -4. Okay, let's see what you can do with this one. -2 minus 4. How can I rewrite it so it's adding the opposite? Tell me what to write down. -2 plus -4. Now, is that one easier to solve? Probably. If I look at -2 plus -4, my signs are the same. What's going to be my answer? -6. Since the signs are the same, add the 2 numbers. 2 plus 4 gives me 6, and keep the same sign. Which, well, okay, hang on a second. Let me explain what I said, that this is easier. If you have had trouble figuring out how to get the signs correct and get the, whenever you're working with positives and negatives, get the right answer. This is a rule that if you rewrite it, you only have to know the rule for adding, and it makes it easier to understand how to follow the pattern. If you came in here and you're saying, I have no trouble with this, I can do positives and negatives, and I can keep up with adding and subtracting, and you're able to look at that and you are consistently getting the correct answer without changing it to adding the opposite, you don't have to put plus and negative on your paper. I'm just telling you that if you need a tool to help you so you don't mess up, this is a good way to do it. Now, the other thing you want to watch out for is sometimes you sit and you think, I can do that, I can figure this out. If you're not doing it right consistently, start using the rule, okay? So it's kind of depending on where you are. Now, how many of you can look at this one and you just know the answer without changing it to adding the opposite? 3 minus negative 5.
8.
Okay, why is it 8? You said the 2 negatives make a positive. Do you know why? You're adding the opposite. You change the subtraction to addition, the negative becomes positive. So you may be doing it mentally and not realizing that's really what you're doing. Minus a negative is the same thing as plus a positive. And 3 plus 5 is 8. And that's kind of a crazy thought when you think about the number line. How do you start at 3, subtract negative 5, and end up at a positive 8? Well, think about it this way. It's kind of like I'm at 3, and I'm going to go left because it's subtraction, but then wait a minute. This tells me negative or opposite, so I got to go back the other way. All right? So minus the negative is kind of like turn, okay? And then look at this guy, negative 8 minus a negative 12. How many of you just know that one? Okay, you're 20 and you're 4. So what would be something that might help us figure it out? Make it, tell me what to write down if I'm going to add the opposite. Negative 8 plus positive 12. Good deal, because that's adding the opposite, 2 marks. And negative 8 plus 12 is 4. Okay, good. So we're going to use order of operations down here. Let's see if we can clean this up. I want you to do it on your paper. I'm going to combine check, see if you got the right answer. And let's talk about where we start here. So most of you recognize, obviously, I got to start right here at the 4 plus 6, right? Which is how much?
10.
So I copy everything else down just like it is. But when I get to that parentheses, I'm going to put 10. Now, I have the brackets. So I need to clean up what's inside the brackets. How much is negative 3 minus 10?
7.
Okay. We're a little bit confused on that. So I want to make sure I change subtraction to adding the opposite. That means I'm adding negative 3 plus negative 10. How much is that? Negative 13. So I have 2 minus, and inside the bracket is a negative 13. So far, are you with me? Now, what am I going to get?
Negative 14. Oh, multiply?
I've got minus a negative. What did we say we should do?
Plus.
Add the opposite. So I'm going to change that to adding the opposite. Remember, you got to make 2 marks every time you're using adding the opposite. Don't just change one sign. You got to change both. And 2 plus 13 is 15. Some of you got it. Some of you got part of the way, and then you got off a little bit. This is why you want to show me what you're doing, because some of you had everything right except you didn't copy down the minus sign. I could give you partial credit. If you do it all in your head, I have no idea where you got off. Now, look at this one. Tell me what you need to do first.
5 minus 7.
Now, 5 minus 7, I'm looking at that, and I'm thinking, okay, what do you think that's going to equal? some of you know what it is. If I had any trouble with that subtraction, I can change it to adding the opposite. And what I'm really doing is 5 plus a negative 7. And because the signs are different, do what with the two numbers? Subtract. 7 minus 5 is 2. And what sign should that be? Negative, because the 7 is bigger than the 5 and the 7 was negative. So I have a negative 2 plus 3 inside the bracket, and then I have a minus 8 at the end. All right, finish cleaning up the bracket. How much is negative 2 plus 3? Because I'm adding and the signs are different, subtract the numbers, and my answer takes the sign of the larger number. 3 is bigger than 2, and 3 was positive. So now I have 1 minus 8. And if I need to change that subtraction to adding the opposite so I can see what the answer would be using those addition rules, I'm adding a positive 1 and a negative 8. Signs are different, so negative 7 is my answer because I'm going to subtract the two numbers and my answer takes the sign of the larger number. My hunch is we need a bit more practice with this. Agreed? And I'm thinking this may be where you ran into a little trouble on, some of you have finished the review homework. Most of you got a little ways into it and you kind of ran into a few problems. If you were having trouble with sign rules, we've covered those now. So you want to make sure you keep up with that. And I will tell you this is where you got to be really careful. If you say, I don't really need to know those, I can just use my calculator. I've already told you something's coming up where you really do need to know the sign rules. But I will also tell you, if you don't put it in your calculator with all of these brackets and parentheses, your calculator won't know what the correct order of operations is for the problem, and it won't tell you the right answer. Okay, so you've got to make sure that when you put it in, you put it in exactly like it appears on your paper. And so watch out, in some calculators, there's a button to use for a negative number, which is different for a subtraction sign, and it doesn't let you mix and match. I'll just mention on here, we can translate. We won't be doing a lot of that, but I do want to point one thing out. What does the word difference mean? So if it tells you to take the difference between two numbers, which one do you think you write down first? First one you come to. This would mean negative 5 minus negative 12. Okay? Difference means subtract, and you subtract in the order that it's given to you. What does this mean? Negative 2 subtracted from the sum of negative 4 and 4. Now, when I see words like subtracted from or less than, that means it's subtraction, but what kind? Backward. In other words, it's giving me the number that comes after the subtraction sign first. So if I'm going to subtract negative 2 from something, it means I've got to do what comes after subtracted from, and I'm going to do this part first. Then I'll put the minus sign, and this would go after it. Now, what does the word sum mean? S-U-M. The answer to an addition problem. So this would tell me to add up negative 4 plus 4. That's the sum. And then I'm going to subtract negative 2. Okay? If this says 7 less than negative 2, how would I write that one down correctly? 7 less than negative 2. It would be negative 2 minus 7. Think about it like this. Let's say I had asked you, gosh, I was hoping that maybe you could lend me some money today. I didn't bring any cash and I don't have any money for lunch. So let's say that I asked you how much money you had and you said $1. Okay. And I said, oh gosh, $1. That is $4 less than what I need. Okay, how much money would I have needed to get lunch? I would have needed $5. That's not because it's 1 minus something, 5, but it's because it's 5 minus 1. So if I know that it's $4 less than what I needed, then that means that 5 minus 4 would give me 1. So you got to pay attention when it's less than. It is subtraction, but it's not in the right order. Okay, and I think let's stop there, and we're going to pick up with multiplying and dividing real numbers next time. But I will tell you, these rules are a lot easier. Do you guys know? And let's just see how much you remember. If I multiply a positive times a positive, what do I get? A positive. What if I multiply a negative times a negative?
Positive.
I still get a positive. So as long as the signs are the same, I'm going to get a positive. What happens if you multiply a positive times negative? That's when you get a negative. Usually those rules are easier to remember. It's the adding and subtraction that gives you a little more trouble. Now, for those of you who weren't here last time,